Today our discussion is displacement of the spectral lines. I have a question. If I keep a excited atom in free space and it is emitting a radiation or a emission of frequency mu naught, and then I took it and kept it in gravitational field, the question is that will the emission frequency will change for the action that I have done on it? Before giving the answer of the question, I want to discuss an experiment with the clock. Assume a circular disc. Assume a circular disc of radius r and the center is at O and a point P at a distance r from the center. Basically, this is the point and this is the center. This is the center and this is the now I bring two identical clocks. Clock 1 I kept at this point and clock 2 I kept at this point. Clock 1, clock 2. Now I bring two identical clocks and then I kept one clock at the point O and the other at the point P. C1 does not experience any force because C1 is the center, but the point P experience a velocity v due to the rotation about the axis of the disk, and the relation is v is equals to omega r. V is equals to omega r, where omega is the angular velocity of the disk. Angular velocity of the disk. So v is equals to omega r. Here the force is on the particle F is omega square x. Here there is a unit mass. For this case, mass at the point P is 1. The mass at the point is 1. Unit mass. For the unit mass, the force is this, where x is the distance from the center of the particle. So that if we want to bring the unit mass from this point to this point, from this point to this point against the force, then the work will convert into the potential energy. So the potential energy is equals to the negative work done is equals to the F dx. So total potential energy stored in the unit mass equals to minus of the integration of dw integration of du, where du is the negative work done. So minus 0 to in integration 0 to r f dx, because I bring the unit mass from P point to 0 and the distance between 2 points is r, so integration 0 to r. The result is minus omega square r square by 2 is the potential energy gained by the unit mass. Now comes to the clock. Assume the number of tick tick of the clock, means the number of tick of the clock per unit time is V0 at the center, and the number of tick tick per unit time of the clock at the point is V. The relation between them is described by the equation V is equals to V naught, means the number of tick per unit time at the point P is equals to the number of tick per unit time at the center into under root of 1 minus v square by c square. V is the speed that the particle is, and the c is the speed of the light. Here the V is basically this. V is basically this. The particle experiences this velocity v at the point P. So the relation is this. Here the v is very very small with respect to c. So v is approximately v naught 1 minus v square by 2 c square. For the previous system we know that v is equals to omega r. So substituting this, the first equation, we get v is approximately v naught 1 minus omega square r square 2 c square. The interesting thing is minus omega square r square minus omega square r square by 2 is the potential energy. This is the potential energy. So minus omega square r square by 2. So minus omega square. So minus omega square r square by 2 can be replaced by minus u. So we give, so using the given equation we get that v is equals to approximately v naught 1 plus u by c square. U is the potential energy of the unit mass in this system. Now we can apply the same concept or the same result to define the answer of our question, previous question that I have discussed. Basically the frequency is the number of waves passing through a particular point in per unit time, and the tick of the clock is the number of and tick of the clock in per unit time is V. For the planet, for the gravitational potential is Gm upon r for a unit mass. Basically this term is this term basically minus gmr is equals to the gravitational potential. By using this equation and the help of the previous equation, we can derive this formula. that mu naught minus mu by mu naught is equals to gmr into c square, where m is the mass of the massive planet, g is the universal gravitational constant, c is the speed of the light, and r is the radius of the planet. Where mu naught is the frequency of the emission in free space, and the only mu is the frequency of the emission in the presence of gravitational field. So the result is mu naught is not equals to mu. So the conclusion is an atom absorbs or emits light of a frequency of a certain frequency is depend on the potential of the gravitational field in which it is situated. So mu depends on the gravitational potential. So the mu details on the gravitational potential. So the answer of our question is no. Mu naught equals to mu naught.